In section 1.5, we're going to talk about equations, and we're going to start with the simplest forms of equations that we've done in the past and work our way up to more complex equations. When we solve equations, we're finding something called the solutions, but we sometimes call them the roots. Those are the values of the unknown that make the equation true. One of the things that I remind you of is that the order in which you write an equation doesn't matter. So if A equals B, then B equals A. Here's a more reasonable problem, one that you've probably seen before. Sometimes we give you a problem like 5 is equal to 2x plus 3. That's the same as writing 2x plus 3 equals 5. And the reason that's important is because a lot of students are more comfortable if the equation is written with the variable on the left. And that's how we traditionally write it. Most of you know that it really doesn't matter which side of the equation our variable's on. We can still solve it. But if you're more comfortable with it this way, then just remember that equality means that you can switch the order. The simplest type of equation is the linear equation, any equation that's of the form ax plus b equals 0. It's called linear because the variable has an exponent of 1. Now here are some examples of equations that are linear. 4x minus 5 equals 3 is a two-step linear equation. 2x is equal to 1/2 x minus 7 is a linear equation because you could subtract 1/2 from both sides and then finish solving for x. X minus 6 is equal to x divided by 3 is a linear equation because x over 3 is the same as 1/3 x. Some examples of equations that are not linear are x squared plus 2x equals 8. That's really a quadratic equation because the biggest exponent of x is a 2. The square root of x minus 6x equals 0 is not linear. The reason is because the square root of x is the same as x to the 1/2 power. In order to be linear, the biggest exponent of x has to be 1 with no other exponents of x. 3 over x minus 2x equals 1. Not linear, because 3 over x is the same as 3x to the negative first. Remember, in order to be linear, the only exponent of x has to be 1. If there are any other exponents of x, it's not linear. How you learned to solve a linear equation really depends on what teacher you had when you first learned algebra. This is how I learned it when I first learned algebra. My teacher told me to get the x's on the same side by moving the x with the smaller coefficient. Well, 3x is smaller, and in order to move a term from one side of the equation to the other, you need to add its opposite. So the opposite of 3x is negative 3x. So I'm left with 4x minus 4 equals 8 because this canceled. Then I get my constants on the same side. So I'm going to add 4 to both sides, and I get 4x equals 12 because this goes away. And then to get rid of the 4 in front of the x, you divide because that's the opposite of multiplying, and you find out x is equal to 3. And then you plug that back into the original problem to make sure that it's true. This is called the vertical method. And like I said, this is how I learned to do it. Some teachers use something called a horizontal method. It, in essence, did the same thing, but they would write it a little bit different. Instead, they would add 4 to both sides like this. So you would get 7x, these cancel, is equal to 3x plus 12. And then they would subtract the 3x, probably not there. They may have written it at the end like this. And then you would have your 4x is equal to 12, and then x equals 3, and then you go back and you check the answer. I'm going to give you another way of doing it if you want to become more proficient with the graphing calculator. I'm not sure if the teacher you had for Algebra 2 Honors did this or not, but this is the way that I'm particularly fond with. You put this into the y equals function under y1 equals. And then you put the second side of the equation into y2 equals. You graph it, and then you find the x value of the point of intersection. The graphing calculator finds the point of intersection by doing second trace, which is up at the top of the calculator, number 5, intersection, and then hit enter 3 times. The x value you get should be 3. You don't care about the y value, you only care about the x value because that is the value that is the solution to the equation. In pre-calc honors, we work a lot with scientific formulas. And one of the things we learned how to do in algebra, but often tends to be a difficult concept for a lot of students, is solving for one variable in terms of another. In other words, you have an equation that's full of letters, and you want to solve for one of the letters. So the way this works is, if you want to solve for capital M, you need to get rid of g, little m, and r squared. So you have to think about how the inverse operations work. So I'm going to start with this g here. Since this says g times little m big M over r squared, then I'm going to divide by g to get rid of it. Now I'm going to get rid of this r squared. The r squared is being divided on the right side. The opposite operation on the other side would be multiplying it. Last but not least, I want to get rid of little m because I want to solve for big M. Since this is being multiplied on the right-hand side, you would divide it on the left-hand side. And this would be the equation solved for capital M. Now, what order would you write this in? It doesn't matter. I wrote it as f times r squared over g times m. You could have written it as r squared times f over m times g or whatever. The order of multiplication doesn't matter because multiplication is commutative. Sometimes the equations that we're working with are a little bit more complicated when we want to solve for a particular variable. This is the formula for finding the area, the surface area of a rectangular prism or a rectangular box when you know the height, the width, and the length. In order to solve this for W, notice that 2 of the terms have W in it. We'll come back to that in a second. I'm going to start by getting rid of this term. Now, remember that's a term in an equation, even though it says 2 times L times H. That's a term. And to get rid of that term, I got to do the opposite of adding, which is subtracting it. Alright, so this is where I'm at. Now, since both of those terms that are left on the right share a W, one of the things that I can do is I can factor out a W. I know I can factor out a 2 as well, but the reason I'm not going to is because I want to get rid of those 2's anyway. I only want W to be left on the right-hand side when I'm done with this. Now that I got rid of this is W times the quantity, 2 times length plus 2 times height. I can get rid of that by dividing both sides by that expression. So this goes away, and I'm left with the width being equal to the area minus 2 times length times height divided by the expression 2 times length plus 2 times height. After we learned how to solve linear equations, we moved into these things called quadratic equations or equations of degree 2. The general run-of-the-mill quadratic equation is ax squared plus bx plus c equals 0. That's called standard form. There's another way of writing quadratic equations that we learned in Algebra 2, but we'll come back to that at another time. The most basic way of solving a quadratic equation that we learned was by factoring the quadratic and then using something called the zero product property. The zero product property says if you have 2 quantities being multiplied and it equals 0, then either one of the quantities has to be 0 or the other one does. So here's how it worked. In order to solve a quadratic equation by factoring, the equation needs to equal 0. It doesn't, so in order to make it equal to 0, I could do the opposite of 24, which is negative 24. Now it equals 0. Now, just focusing on this part of the equation, in order to factor it, the two numbers that multiply together to give you negative 24, but when you add those same two numbers you get 5, are positive 8 and negative 3. Well, now that I have this in factored form, the zero product property says that either this quantity has to equal 0 or this quantity has to equal 0. And the word or sometimes confuses students because they think they can write one answer or the other. But really that's not how it works. You have to write down both answers. So either x is equal to negative 8 or x is equal to 3 is the solution. This is not the only way of solving it. Another way of solving it is if you set it equal to 0 and you graph it in your calculator by putting x squared plus 5x minus 24 into y1 equals. The solutions are the x-intercepts. So if you graph it, you can just look where it hits the x-axis. And those would be the solutions. And I claim to you, if you graph x squared plus 5x minus 24, it will hit the x-axis at negative 8 and at positive 3. Sometimes the quadratics we get are called simple quadratics. Simple quadratics are the ones where x squared is just equal to a number. So if x squared is equal to c, then x either has to be the square root of c or has to be negative square root of c. In other words, if you have x squared is equal to 25, then x either has to be 5 or negative 5. The reason that it's 5 or negative 5 is because remember that squaring a number always gives you a positive. So 5 squared is 25, but negative 5 squared is also 25 because it's negative 5 times negative 5. So in this problem, not all the answers come out to be integers. For example 5a, if x squared is equal to 5, then x is going to equal the square root of 5, or it's going to equal negative square root of 5. For part b, though, that one's a little bit different. X minus 4 is going to equal the square root of 5, or x minus 4 is going to equal negative square root of 5. What ends up happening is I end up with two equations that I need to finish solving. One of them is going to be x equals positive 4 plus the square root of 5, and the other one is going to be x is equal to positive 4 minus the square root of 5. Another way of solving quadratic equations is by doing something called completing the square. I'm going to honestly tell you, we almost never use completing the square to solve quadratic equations. However, the technique that I'm about to talk about is very important for when we study something called conics. Conics will be our study of circles, parabolas, hyperbolas, and ellipses. So keep that in mind, that even though this is not a good way to solve a problem, there are better ways to do it. This is a good process for something we're going to do later on. A perfect square trinomial is one in which the middle term is the sum of a number and itself, and the third term is the product of those same two numbers. So because this is 3 plus 3 and this is 3 times 3, this is called a perfect square trinomial. Perfect square trinomials do not always have integers. So here's another example of a perfect square trinomial. Let's see. I gotta think about this for a second. X squared plus x plus 1/4. This is 1/2 times 1/2. The coefficient in the middle, which is 1, is 1/2 plus 1/2. What if I didn't tell you the middle term, though? What if I didn't tell you the last term? What if I just said x squared plus 3x plus blank, and I said, what would the third term need to be in order for this to be a perfect square trinomial? Well, it's very easy to find. All you have to do is take the middle term, divide it by 2, and then square it. So in the equation, ax squared plus, I shouldn't do ax squared, let me do x squared x squared plus bx plus c. C can always be found by doing b divided by 2 squared. So here's how you can use completing the square to solve a quadratic equation. What you do is you take the first 2 terms in the trinomial, and that's what you're going to complete the square on. You're going to add a third term. What I'm going to do is I'm going to leave the plus 13 here. And anything that you add new to one side of an equation, you must also add to the other side of the equation in order to keep the equation balanced. I said earlier that you find the third term by taking the middle term, b, dividing it by 2, and then squaring it. Well, anytime you square a negative, you're going to get a positive. So negative 8 divided by 2 is negative 4. Negative 4 squared is 16. All right. The reason that perfect square trinomials are important is because they're easy to factor. This, we said in an earlier lecture, is x plus 3 squared. And this one would be x plus 1/2 squared. If this were a minus sign instead of a plus sign, this would become a minus sign. So this becomes x minus 4 squared, because it's really x minus 4 times x minus 4. Those are the two numbers that multiply to give you 16, but when you add them together, you get negative 8. And I'm going to subtract that 13 on the other side. So now I get x minus 4 squared is equal to 3. Well, that looks like an example I just did a few minutes ago. I can solve this by taking the square root of 3, but remember that there are actually 2 solutions. One of them is x minus 4 equals the square root of 3, and the other one is x minus 4 equals negative the square root of 3. So the answer would be x is equal to positive 4 plus the square root of 3, and x is equal to positive 4 minus the square root of 3. This would have been easier gotten by using the quadratic formula, which I'll review later on. Now let's try this with a more complicated problem, a quadratic whose leading coefficient is not 1. In order to complete the square to solve an equation, the leading coefficient has to be 1. So the trick I'm going to pull off here is I'm going to start by factoring out the 3. The reason is all 3 terms are divisible by 3. So I'm going to get x squared minus 4x plus 2. Now I'm going to go back and I'm going to complete the square, and you always complete the square using the first 2 terms in the trinomial. So I'm going to use 3, and I'm going to do x squared minus 4x plus something that we're going to come up with in a minute, plus 2, is equal to 0 plus blank. And I'm going to put a little star here because this is a little bit different from the previous problem. Remember, we fill in the blank by taking the middle term, dividing it by 2, and then squaring it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. The reason the star is on the other side is because the number that goes in that blank is not 4. Remember that we factored out a 3 originally. I have to factor that 3 back in to get the number that goes on the other side. So the number that goes on the other side is actually 12. It's 3 times 4. Now I'm going to rewrite this in factored form. The trinomial is x minus 2 squared. And then I think the easiest way to attack this problem is to now divide by 3. So I'm going to get x minus 2 squared plus 2 is equal to 4. And then I'm going to subtract the 2, and now I have an equation that looks similar to one we did earlier. My 2 solutions are going to be x minus 2 is equal to the square root of 2, and the other one is going to be x minus 2 equals negative square root of 2. And then I have to add 2 to get the final answer. So I get 2 plus the square root of 2 as one of my solutions, and x equals 2 minus the square root of 2 is the other solution. And I repeat again, the process of completing the square is not my favorite for solving a quadratic. I prefer the quadratic formula for answers that look like this. They're called irrational solutions. However, the process of completing the square will come back to haunt us. In the not so distant future, I should say.